Dear students, Assalamu alaikum. So in this tutorial we're going to talk about ARP. Okay, so we're going to talk about ARP and DNS. So at first we're going to talk about ARP or Address Resolution Protocol. So basically I'm going to talk about the theoretical part first, and then I'm going to move into the practical part, which I want to show you on Cisco Packet Tracer. Okay, so let's just learn the theory first. So basically, what is Address Resolution Protocol? Address Resolution Protocol, or ARP, is a protocol by which we can actually find the physical address using the network or logical address. Alright, so there are basically two types of addresses in terms of internet. One is called physical address and the other is called logical address. Alright, so the physical address is usually known as the MAC address, and the logical address is usually known as the network address or the IP address. Alright, so we are usually familiar with both of them, the physical and logical address, but we just know them by their other names like IP address and MAC address. So you just have to keep in mind that when I say physical address, I mean MAC address, and when I say logical address, I mean the IP address. Okay, so at first I want to show you a scenario. Okay, so let's consider that I have two computers. One is host A. Let me just take a marker there. Okay, so one is host A and the other one is host B. So these are two computers and I want to send data from one host to another. So say for example, I want to send data from host A to host B. Alright, from host A to host B. Okay, so to send the data to my destination, I know that I need the IP address of that destination. But what you need to understand is knowing the IP address of the destination only is not sufficient. Alright, so we just cannot send the data by knowing the IP address only. We also need some other information, and that other information is actually known as the physical address or the MAC address. So ARP helps us in that perspective, that it helps us to get the physical or the MAC address of that destination machine. For example, if I want to send data from host A to host B, then I definitely know I may definitely know the IP address of host B, but I also need to know the MAC address of host B. If I don't know the MAC address of host B, then I can't send my data to host B. So to send the data perfectly, I need the MAC address along with the IP address. Okay, so let's think about the scenario now. So if I want to send the data from host A to host B, then whenever I send press from host A, then a packet is created. All right, so that packet actually holds different kinds of information. So these are some examples of those information. So one is sender MAC address, and then there is sender IP address, and there is target MAC address, and there is target IP address. So what does it mean? Okay, the sender here is actually host A. Alright, so sender MAC address means the MAC address of host A, and the IP address, the sender IP address actually indicates the IP address of host A. So this is the IP address of host A, and here the target is actually host B, or my intended destination. Alright, so this target MAC address and target IP address indicates actually host B, but you can see right here that we have the sender MAC address, the sender IP address, and the target IP address, but we actually don't have any kind of target MAC address. You can see that this point right here where I'm putting an underline. Okay, so right there the target MAC address is all zeros. So why do we put all zeros right there? Okay, so this is the part where the ARP actually helps. So whenever we want to send data from one host to another, we actually know the MAC address of the sender, because we are actually sending the data. That data is being sent from host A, so the packet where the data resides, that packet actually knows the sender MAC address. Alright, because it is being sent from the sender. Okay, so it also knows the sender IP address for the same reason, as it is being sent from the sender. So it already knows the sender MAC address and the sender IP address. But in case of the target, we can see that the packet only has the information of the target IP address, because it knows that it has to follow that IP address to go to the destination, but it does not know actually which device it should go into. That means to know a device specifically, we need to know the MAC address for that device, because MAC address is known as physical address. All right, so we need to know the physical specification, the physical identification for that specific device. So when this packet is going to the destination, it only knows the IP address of that destination, but it does not know specifically the MAC address or the physical address for that device. So that's where actually ARP helps. So ARP helps us to ARP helps us to know that MAC address, and after that the transfer actually takes place. And that's the reason we have put all zeros in this field, because when the packet is going for the first time, it doesn't know the MAC address of the destination. That's why usually all zeros are put in that specific field, the target MAC address. All right. Okay, so there is another fact which you need to know, is that whenever this packet is actually sent to the destination, then this packet, this ARP packet, it is called an ARP packet. This ARP packet is usually known as a broadcast packet. All right, it is actually known as a broadcast packet. So why is it called a broadcast packet? Okay, so it is called a broadcast packet because this ARP packet is actually sent to all the hosts that are connected to the sender. Okay, so let me show you what I mean. So let's just consider okay, so let's just consider this scenario. So I'm sending data from PC1. all right, so I can see that there are multiple PCs connected along with this PC via a switch. Okay, so this is a device, this is called a switch. So if I want to send data from PC1 to let's say PC2, okay, so I want to send the data from PC1 to PC2. So how does it happen? So the ARP packet is created, and the packet knows the MAC address and IP address of PC1. It knows the IP address of PC2, but it does not know the MAC address of PC2. So it needs to know the MAC address of PC2. So the packet is sent to the switch first, and after that the packet is sent to all possible destination from that switch. Okay, the packet is sent to all possible destination from that switch, because it still doesn't know where it should go. So that's why at first it goes to the all possible destination from that switch. Okay, so but after that you can see that when the packet actually traveled, the packet only knew the IP address of the destination. All right, so since the packet only knew the IP address of the destination, so the packet tries to match that IP address with the IP addresses of those individual connections. Okay, so when the packet reaches PC4, it tries to match the IP address of PC4 with the IP address of its own. When the packet reaches PC3, it tries to match the IP address of its own with PC3. When it reaches PC2, it tries to match the IP address of its own with PC2. Okay, so you can see that since the packet only held the IP address of PC2, so only in case of PC2 it will match the IP address of this computer. Okay, so it will definitely not match the IP address of PC4 or PC3. So the only match we will be getting is here at PC2. So since this will match, then there will be only one response coming from PC2. The PC4 and PC3 will not respond to that query. You can see that PC1 sent the packet, and the packet reached PC2, PC4 and PC3, all the possible destinations, because it was basically a broadcast packet. But only PC2 responded because only PC2's IP address actually matched with the packet's actual IP address. That's why only PC2 actually responded. So PC4 and PC3 did not send a response. Only PC2 responded, and that response packet will reach PC1, and that's how PC1 will make sure that yes, it will need to that it needs to get connected to PC2. Okay, so that's what is actually happening right here. Okay, so let me just move into this part again. So here I have already described that host A is sending a packet. It knows the sender MAC address and the sender IP address. It doesn't know the whole destination MAC address, so it puts all 0 right there, and it knows the destination IP address, so that's why there is a value. And then actually this part actually occurs, the broadcasting part. So it sends the packet to all possible destination. In our scenario we have just only one PC, but let's say there are multiple PCs, like there is another PC and there is another PC. So the packet goes to all possible destinations, but only the packet whose IP address will match with the only the destination whose IP address will match with the packet's target IP address, only that destination will respond. So in this case host B will respond. Okay, so when this response is going, you can see that this field is not empty anymore. Okay, so there is something in this field. So but don't get confused, because you can see right over there this target MAC address is actually matching with this initial source MAC address. Okay, so let me just show you what is happening over here. So since this host B is responding right now, so this host B is actually working as the source now. Okay, so this is working as the sender now, so that's why its own MAC address is embedded into this field over there. You can take a look over here, 00A02470. Yeah, it just matches it with this one. Okay, so this is working as the sender now. So this is sending its MAC address into this field, and in the target MAC address, the target is actually host the host A now. So that's why this MAC address actually matches with the MAC address of this initial sender's MAC address. So what I'm trying to show you here is that in this response packet, you can see that there is no field which has all zeros over there. Okay, all the fields are filled up with specific valid information. There is no field with all zeros or all empty, something like that. So this is how actually ARP works. So we took help from of our IP addresses, the source IP addresses and the destination IP addresses and source MAC addresses, and with the help of those IP addresses we were able to find out the MAC addresses of my destination. So in this case my destination was host B, and I was able to find out the MAC address of host B by using this procedure. So let me just review that in short. That initially I wanted to send some data from host A to host B. Alright, so since my sender is host A, so it created an ARP packet. Okay, so it created an ARP packet, and okay, so it created an ARP packet, and this packet had different fields: sender MAC address, which indicates the host A's MAC address, and sender IP address, so host A's IP address. And then the target MAC address field was completely empty because it initially didn't know what the MAC address should be, so it was empty, 00000 and everything 0. And here you can see the target IP address is the IP address of my intended destination, host B's IP address. You can see that it matches with this one. Okay, so but however there can be multiple devices connected at the destination. Alright, so there can be like 3, 4, 5, etc., many different devices connected at the destination, but only one will respond. The device which will respond, in this case it is host B, because you can see that the target IP address matches with the IP address of host B. So only the device which whose IP address will match with the target IP address, only that device will respond. So in this case it is host B. So in the response packet, okay, so let me just change my color over there. So that I can. Okay, so let me just okay, I guess. Yeah, so this is the response packet right now. So now host B is sending a response. So in this response packet, you can see that it also created a response ARP packet, but in this case there is absolutely no field where we can see all zeros. So what happens in the response packet? Then in this packet, this host B is actually embedding its own MAC address into this packet. So let me just show you over here that whenever the response is coming from host B, then this host B automatically becomes the sender this time. Alright, because the packet is coming from host B, so it becomes the sender. So if you can take a look at the sender MAC address over there, you can see that it is actually the MAC address of host B, and this is the IP address of host B. And since this is the sender right now, it is sending the packet to host A, so host A's MAC address over there is actually the target MAC address. All right, so the point here is that in this packet you can see that there is absolutely no field where we can see all zeros, or there is absolutely no field which is absolutely empty over there. All the fields are filled up with completely valid information. Alright, so all the fields are filled up with completely valid information over here. So that's how ARP actually works. So we initially did not know the MAC address of this host B, but with the help of our source MAC IP and target IP address, we were able to find out the MAC address of host B, which is just written over there. So now our both of our hosts know every possible information they need to communicate further. So initially this communication didn't know the target MAC address, but now we know the MAC address of this destination, our intended destination host B. So that's how ARP actually works. So this is basically the theoretical part over here. So we're gonna see the simulation, and we're gonna see that in Cisco Packet Tracer, and we'll be seeing it next.